So for independent events, if two events A and B are independent, it's a pretty important result, then the probability of A and B, we can calculate that directly from the probability of A and the probability of B. You just multiply them. Only if they're independent though, okay? So like the probability that I put on a blue shirt today and the probability that a meteor strikes the Earth, those two things are not related to each other, right? The blue shirt's not pulling the meteor towards Earth. I can find the probability of both those things happening by multiplying the probability that I put on a blue shirt to the probability that a meteor strikes the Earth. Okay? So this one they just give us straightforward probabilities. They don't have it in a word problem yet. A is 0.90. A and B are independent, so you just need to plug in 0.54 in for the probability of A and B. So just another equation to solve. You want to solve for the probability of B, so that means you've got to divide both sides by 0.9 to get B by itself. So that gives us 0.6 for a probability. Let me see if I can get another one. Maybe a word problem would be good. Here we go. If you roll a fair die and then roll a second fair die, what is the probability that you roll 1, 2, or 3 on the first die and a 5 on the second die? So start with the first probability. What's the probability that you roll a 1, a 2, or a 3 on a fair-sided die? There's 3 out of 6 ways of getting those options, right? So it's a 1/2 chance. And then what's the probability of rolling a 5 on the second die? There's only 1 out of 6 ways of doing that. Now the two dice rolls don't impact each other, right? Getting a 3 on the first dice doesn't mean you're going to get a 3 again on the second dice. Getting a 5 doesn't mean you're going to get a 4 on the second time you roll it. So they're independent. So to find the probability of both these things happening, we multiply. So 3 over 6 that's 1 over 2 times 1 over 6. And remember, with fractions, you multiply straight across the top and straight across the bottom.